Hi, it's Bruce. Welcome to my Colorado Rocky Mountain lab, and today we're taking a look at a VIZ made by RCA. It's a WP707. It's called a dual supplyist. It's a dual channel 0 to 25 volt power supply. Provides 2 amps per channel. They are independent power supplies. They can be connected in series and you'll get 0 to 40 volts of output at up to 2 amps. I believe you can also connect these things in parallel, although they don't go into that in the manual. Probably it would be a safe thing to use a diode, feed through a diode on each channel before you parallel them, but that would give you 0 to 20 volts up to 4 amps on the output. You'd have to be careful to keep your voltages the same at all times in order that they don't load the power supplies improperly. But anyway, it also has 2 3-digit readouts, which was unique at the time. Not too many people had digital readouts, digital voltmeters. And this voltmeter, it'll measure voltage if the switch on each side is in the volt position, or it'll be reading amps if it's in the other position. Okay. The other thing nice about it, there's another switch on each channel. If it's to the left pointing towards the output, you're measuring the output of the power supply. And if it goes to the right, it makes this 3-digit panel meter an independent meter, and you can feed a voltage in on these terminals on either side, and you can have up to 2 different voltmeters additional for your bench. Not something I utilize much. Don't have much need for a 3-digit meter. I've got bunch of meters, but at the time it was a crazy feature. Okay, so what we're going to try and do is to demonstrate the current limiting aspect of this thing. So let's go ahead. We're going to put ourselves into the current mode for measuring. And we're going to leave ourselves on the output. I'm going to literally short the output. I'm going to reduce this at the moment. Okay. Push on the reset button and set the output to give the current limiting that you want. I'm going to go for an amp. Okay, that's an amp. Reset myself. Voltage wise, we see we got the voltage there. So now, did it work? Were we able to literally set the current limiting so that when we hit 1 amp we shut down? Let's find out. I'll hook this electronic load device on here, and I'm going to pick you up so that we can take a look at what we're doing here. Okay, and I'm going to adjust this load device to apply a load. There's a 1/4 amp, 0.38, 0.5, 6, 7. You notice that we still have voltage. 8, 8, 7. 8, 9, 9, 2, 9, 9, 9, 8, and I'm going to hit, there's 1. You notice our voltage went down, so we've gone, and here's our indication, a little dot in the corner there that says that we've exceeded our current and we need to do something about that. So I remove the load and I go ahead and hit the reset button, and we're back to 15.5 volts out. So the current limiting worked. I set it to 1 amp and it shut down at 1 amp. It's a nice feature. Okay, another feature of the dual supplyist is that you can set these power supplies in series so that you can double your voltage output. It's because they're independent and we don't have to worry about grounds and so on shorting each other out. So how do we do that? Well, we take let's say we take the positive output of the left channel and we feed it to the negative input of the right channel. Make sure we're set to the voltage on both channels that we want to be set to. So like I'm set at 25. And at this point now, what I should find when I connect my meter up across both channels, so I'm measuring from the negative of the left channel to the positive of the right with the short in between, I should see now that I'm set at about 50 volts. And I am reading 49.975, so as close as I could get with the one-digit decimal place. A slight tweak on either one will give me 50 volts. I'm still reading 25 on both channels. And I got 50 volts even. So there we go. So the series addition of the power supply voltages works. And the output should be good to 2 amps, as each output is capable of 2 amps. So there's your series connected power supplies. Okay, so what I want to do here is to demonstrate the parallel connection of the power supplies to provide more current. And what I've done to facilitate this, protect the circuitry in each of the channels, I've taken a bundle of 1N4007 diodes. They look like this. And it's a 1 kilovolt 1 amp diode. Just to be on the safe side, I bundled 4 of them in parallel, so each capable of producing an amp through it. So I should be able to pass through 4 amps, and I'm only expecting to pass through 2. So I have a 200% capability here, diode-wise. So I've got a safety margin. And I've done that for each channel. So I've got a bundle of 4 here and a bundle of 4 here. The cathode is connected to the positive terminal. The anode is the output on each side. And I've taken the output of the right channel and I've fed it to the output of the left channel. So that's in parallel. And then I've taken the negative jack and I've brought it over and connected it directly to the negative jack on the left channel. So we're totally in parallel. And then we take the output leads here, and the positive lead, you can see, goes right back to my load. Okay, so then I take the negative lead out and I bring it back into the load unit. And this load unit represents a resistor or whatever kind of network that I would have as a variable load on the output. And I expect it to be able to draw, we're gonna go for 3 amps, okay? Because each channel is capable of 2. Neither one is capable of 3, but together I should be able to produce 3 amps and still have a safety margin. So I'm going to do that. All right. So I'll try and lean back here and give you just an overall picture. Once again, I'll come out of the diode pack and I feed the output of the diode pack on the left channel. So the output of my right and my left are in parallel, and I've used the diodes to prevent from backfeeding into the circuitry. Then I come out, go into my load center, and I come out of the load center and go back to the negative lead, which is also in parallel with the other channel. So there we go. Let's we're feeding in 20.6 volts out of both channels, and our load center is reading 20. Well, why is that? Well, that's because we've got one diode drop on each channel, about 0.6 volts. So we'd expect to have a drop there. And it is showing it to me, so that's good to know. Let's go ahead and see if we can produce 3 amps. Okay, there's 0.5, 6, 7, 9, 1, 1, 3, 1, 5, 1, 6, 1, 8, 2, 2, 6, 2, 8, 2, 9, 3.12. So obviously we have no problem producing 3. Okay, so we've drawn 3 amps. We're getting about 19.4 volts. My fan decided to turn on the load center here to keep cool. We see we've got 20.5 volts out of each channel right now, so we've dropped a little bit in voltage on the output. Not much, 1/10 of a volt. And we are also seeing a loss in the cables here, but we are producing 3 amps at about 20 volts, which is what we were aiming to do. So let's go ahead and shut this thing off. Remove the load. Okay. And let's go ahead and disconnect. We have no current right now flowing through anything, so there's our demonstration of the parallel load. So what we're going to do, we're going to test the meter's accuracy at 1 amp, and then we're going to test it at near its full rated load of 2 amps. We're not going to actually go to 2 because we don't want to blow the breakers on these things, but we can go very close. We'll go to 1.95, essentially 2, and we're going to see how it agrees with my 2 Hewlett-Packard meters that are on the bench. And then we're also going to take a look at the ripple noise at 1 amp and at 2 amps. And we're going to see if we stay within the 10 millivolts peak to peak that's quoted on the spec sheet. So bear with me. We're going to go ahead and set this thing up and we'll get going. Okay, so we've wired up this VIZ 707, WP707. Got the left channel feeding into an 8 ohm resistor here. But we've got everything wired so that we're measuring the current going through it on this HP on the bottom. And then we're measuring the voltage across the leads on that other HP on the top. And we're going to compare that to the current readings that we get on the meter. And right now we're getting 1.00 amps. We're getting 1.000 amps on the HP. If I switch to volts, I say I have 8.4 volts. And I've got 8.42 volts on the HP on the top. Quite rounded, that is 8.4. So the meter is looking good. Then I'm feeding the voltage, AC voltage, well, actually I'm feeding the DC voltage with an AC superimposed on it, to this HP amplifier, which has a blocking capacitor in it. So it blocks out the DC, but it lets the AC ripple go through. And I'm amplifying that ripple by a factor of 10. And then I'm feeding that signal from the output into this oscilloscope up here. And that's the waveform I'm getting. And that's at 50 millivolts per division right now. So any reading I get on here, I've got to divide by 10. Well, that's something. So we need a little more gain to see what we're dealing with. I'll try it. Looks to me like we're going up 2 and down 2 divisions. And that right now is at 10 millivolts per division, so that's up 20, down 20. So that's 40 millivolts according to the meter, or to the oscilloscope. However, we got to remember we're multiplying everything by a factor of 10. So divide that 40 by 10 and you got 4 millivolts peak to peak. And that's at a current reading of 1 and a voltage at 8.4. So we're not at full load yet, but it's a good start. And if I was to move the leads to the right channel, oh, again I got 1 amp. I've got 1 amp, 8.4 volts, and 8.4 volts, so that's good. And we are getting an even smaller noise reading, ripple reading on this. Well, yeah, it was up 20, down 20 before. We're up 10 and down 10 now. So we're about half the noise that we had on the other channel. Don't know why that is, but we're still within specs either way. Let's go ahead and turn this voltage and current up. And with an 8 ohm load, and I can only put out 2 amps. That means I should only be able to put in about 16 volts. So let's see if we can get anywhere close to 2 amps. And I'm going to stick right around 1.95. Going up to 2, that's the limit, so you could roll a breaker, and that's not good, so let's not do that. But we are right now at 1.95 amps, 1.95 on the Hewlett-Packard, 16.4 volts, 16.4 volts on the Hewlett-Packard. So we're agreeing meter-wise. And what are we doing on our noise now? Well, we got a little noisier. Okay, so we're going up to about 1.4, down to about 1.4, so that's 2.8 times 10 millivolts, that's 28 millivolts. And then we got to divide by 10, so we're about 2.8 millivolts of noise, of ripple. And that's at basically full load, 1.95 amps. Okay, let's set up channel, the left channel, to be similar. Okay. All right, we're going to bring ourselves up to 1.95. Okay, so we've brought ourselves up to 1.95 amps, both on the HP, and it's also on the left channel. Going to voltage, we got 16.4 volts, which is the same we had on the right channel, and we got 16.45. You know, you could argue that we could round on the 4.5 to, but whatever. We take a look at the output, and we are at essentially full load, and we see that we have a noisier output on the left channel, but all right, looks like we're going down 2 and up 2. So that's 40 millivolts, and then you divide by 10, which would be 4 millivolts. So we're getting 4 millivolts peak to peak out of the left channel, and about 3 millivolts peak to peak out of the right channel. And our spec says no more than 10, so we're well within that, which is a very nice thing to see. So we've tested our meter capabilities. and we've tested our ripple output on both channels, and it's good. Well, I hope you've found the demonstrations both instructive and interesting. The unit performed well. It's doing a great job. Looks good. Always like my equipment to look good. So I appreciate you listening, and happy bidding.